Welcome. The history of the software engineering. The beginning from 1945 to 1965, the term software engineering first appeared in the late 50s and the early 60s. Programmers have always known about civil, electrical, computer engineering and debated what engineering might mean for software. The NATO Science Commit sponsored two conferences on software engineering in 1968 and 1969, which gave the field its initial boost. Many believe these conferences marked the official start of the profession of software engineering. Software crisis from 1965 to 1985, software engineering was spurred by the so-called software crisis of 60s and 70s and 80s, which identified many of the problems of software development. Many software projects ran over budget schedule. Some projects caused property damage. A few projects caused loss of life. The software crisis was originally defined in terms of productivity, but evolved to emphasize quality. Some used the term software crisis to refer to their inability to hire enough qualified programmers. Cost and budget overruns. The US 30-60 operating system was a classical example. The OS over 360 operating system was classical example. This decade-long project from the 60s eventually produced one of the most complex software systems at the time. OS over 360 was one of the first large 1,000 programmer software project. Fred Brooks claimed in the mythical Man Month that he made a multi-million-dollar mistake of not developing a coherent architecture before starting development. Property damage. Software defect can cause property damage. Poor software security allows hackers to steal identities, costing time, money, and reputations. Life and death. Software defect can kill. Some embedded system used in the radiotherapy machine failed to catastrophically that they administered lethal doses of radiation to patients. The most famous of these failures is of the Thrak 25 incident. In 1985 to 1989, the silver bullets. For decades, solving the software crisis was paramount to researchers and companies producing software tools. Seemingly, they trumped every new technology and practice from 70s to 90s. A silver bullet to solve the software crisis. Tools, discipline, formal methods, process, and professionalism were touted as silver bullet. Tools especially emphasized were tools, structured programming, object-oriented programming, case tools, ADA, documentation, and standard were touted as silver bullet. Discipline. Some argued that software crisis was due to the lack of discipline of programmers. Formal methods. Some believed that formal engineering methodologies would be applied to software development, then production of software would become as predictable an industry as other branches of engineering. They advocated proving all program correct process. Many advocated the use of defined process and methodologies like the capability maturity model. Professionalism. This led to work on a code of ethics, licenses, and professionalism. In 1986, Fred Brooks published his Silver Bullet article, arguing that no individual technology or practice would ever make a tenfold improvement in productivity within 10 years. Debate about Silver Bullet raged over the following decade. Advocated of ADA component and process continued arguing for years that their favorite technology would be a Silver Bullet. Skeptics disagree. Eventually, almost everyone accepts that no silver bullet would ever be found, yet claims about silver bullet pop up now and again, even today. 1990 and 1989, the rise of the internet led to very rapid growth in the demand for international information display. Email system on the World Wide Web. Programmers were required to handle illustration, maps, photographs, other images, plus simple animation at a rate never before seen, with few well-known methods to optimize image display storage, such as the use of thumbnail images. The growth of browser usage running on HTML language changed the way in which information display and retrieval was organized. The widespread network connection led to the growth and prevention of international computer viruses on MS Windows computer, and the vast proliferation of spam email became a major design issue in email system, flooding communication channel and required semi-automated pre-screening. Keyword search system evolved into web-based search engine, and many software systems had to be redesigned for international searching, depending on search engine optimization technique. Human natural language translation systems were needed to attempt to translate the information flow in multiple foreign languages, with many software systems being designed for multi-language usage. Based on design concept from human translator, typical computer use base went from hundreds or thousands of users to often many millions of international users. 2020 present lightweight methodologies defaults. Trend in early year from 2000 to 2020 focused on improving the efficiency of development process, agile method, model-driven development, software product line, aspect programming, and experiment trend were process and procedure improvement. These trends originated within the discipline of computer science, information technology, and software engineering. The STEM hierarchy in the following year, 2021-2023, these trends continue, but more efficient software development approaches are called DevOps for development and operations. Also, during these years, trends in other areas have significant impact on software engineering, on the types of problem addressed, on quality goals, especially security and privacy, on process and procedure risk, and the scale of the environment, that infrastructure, data, computing sources, user volume, and diversity. To get a handle on all these trends, we look at the impact on the model used in software engineering, which will indicate what changes might come in the practice of software engineering. Trends from 2000 to 2020 continued along with many new trends. They are listed below along with the software engineering model. Impact on environment and computing process model. DevOps, the set of organizational practice and tools to improve organizational capability to deliver more efficient application and service. Cloud computing over the network delivery to client of computing service and information technology resources from a network of servers. Quantum computing using quantum computer based on quantum physics. Its units of storage is qubit. Qubit can hold 2 digital bits, which get super big very quickly. Access and authentication to practice and tools to manage and control access to organizational digital resources. and identification of authorized user, cybersecurity, technology to protect system, network devices, and data from attacks, special platform, internet system that enable virtual relationship and sharing of all types of digital data among individuals, group, business, organization, and countries and communities, inducing a very large number of internet connection and complex web relationship. Big data, the amount of data that is too large to be practically processed by traditional methods. Impact on architecture model and the database model, distributed and decentralized system, a system distributed over the internet without centralized control software. Blockchain and distributed decentralized control algorithm, first used for Bitcoin management, now generalized to refer to distributed database of list of transactions stored on a peer-to-peer network of servers. Net database system, NoSQL database model for representing and processing unstructured data, multiple data types, and large amount of data. Impact on programming language model. New language, JavaScript and Java are popular language for mobile application, Python for web application, data analysis and data visualization. Newer language have features that emphasize support for web programming, such as minimal code and no runtime overhead, and are compatible with Java and JavaScript. Kotlin is an example. Software application libraries, specialized programming libraries, for example, for data analysis, data visualization, business automation, verification and validation, sound and image recognition and processing, and machine learning. The vast summary of current trend and the model. The impact indicate which model